If $10,000 is invested for T years at 9% compounded annually, the future value is given by this equation. Notice, this is compounded annually. We worked with that other equation with compounded continuously. In how many years will the investment go to $45,950? Well, so we have $45,950. That's going to equal our 10,000 times 1.09 raised to the t power. First thing I do is divide by the 10,000, and I then get 4.595 equals the 1.09 to the t. Change that to exponential form. It'll be the log base 109 of 4.595 equals the exponent t. Well, how do we do this? We know. Change a base formula. Log of 4.595 divided by the log of 1.09. Grabbing my calculator, I find out this is a 7.69. We have $10,000 invested for T years at 9% compounded annually. The future value is given by S equals 10,000 times 1.09 to the t. Now notice this is compounded annually. That's different than the compounded continually equation. In how many years will an investment grow to $45,950? So my 10,000 times 1.09 to the t equals the 45,950 divided by 10,000, I get 1.09 t equals 4.595. Then change in exponential form. My exponent equals log base 1.09 of 4.595. Use the change of base formula. It'll be the log of 4.595 divided by the log of 1.09. That turns out to be 17.6956, or maybe you want to say it in 18 years. Sometimes we have exponential equations and we want to solve them using our logarithmic properties. To solve an exponential equation using logarithmic properties, rewrite the equation with a base raised to a power on one side. Base raised to a power on one side. Take the log, either base e or 10, of both sides, and then use a logarithmic property to remove the variable from the exponent and solve the variable. Now that sounds like a lot of words, but let's see how it really works. We have a base raised to an exponent equal a number. So I'm going to take the log of both sides. I'm going to take the log 4,532. That will equal the log of 8 to the 4x. But this is an exponent, so it can move out to the front. Log of 4,532 equals 4x times a log of 8. And now I have my x here. And 4 and log 8 are multiplied by the x, so that the x can turn out equaling the log of 4532 divided by 4 times the log of 8. And this then is the exact answer. Once I use my calculator, it is no longer exact. And I find out that this is approximately equal to 1.0122 when I use my calculator. When you put that in the calculator, make sure you put parentheses around your denominator. Sometimes parentheses around the numerator. This one's a little more complicated. First thing I would do is divide both sides by 9, since that will go in easily. 4 to the 3x minus 2 equals 20. Now I can take the log of both sides. So the log of 4 to the 3x minus 2 equals the log of 20. Now I can move my exponent out front, but make sure you use parentheses. So it'll be 3x minus 2 in parentheses times the log of 4 equals the log of 20. Use the distributive property of 3x times the log of 4 minus 2 times the log of 4 equals the log of 20. Continuing that up here, I'll be adding 2 log 4s to each side. So I'll have 3x times the log of 4 equals the log of 20 plus 2 times the log of 4. And then here's my x, so I can divide. X will equal the log of 20 plus 2 times the log of 4 divided by 3 times the log of 4. That's the exact answer. My approximate answer is equal to 1.3870 to 4 decimal places. When you enter that in your calculator, put a parentheses around the entire numerator and a parentheses around the entire denominator as you're entering those into your calculator.